Our task is to construct a box, at least on paper, cut from a square piece of cardboard with a square removed from each corner, and then the remaining sides folded up. And when we do that, we'll have an open top box. So the length and width of each of these squares is x. X and x. And then now, once we fold that up, the distance will become 36 minus 2x. And the distance from here to here will also be 36 minus 2x. And here's a three-dimensional representation of the box. And so this will be 36 minus 2x. 36 minus 2x, the length of this side, the length of this side, and the height will be x. Now here's a hint. Make your life for this problem a little easier. Factor 2 out of these two lengths. So we get a 2 times 18 minus x equals 2 times 18 minus x. So now we're ready to state the function that describes the volume of this box as a function of x. So v of x equals x times 2 times 18 minus x times 2 times 18 minus x. And this equals 2 times 2 is 4, x, and then we have 18 minus x, and that quantity is squared, and that's our volume as a function of x. Well, this was part A, finding the equation of the function describing the volume. Part B has to do with finding the volume if x is 10 inches. So v of whatever equals 4 times whatever times 18 minus whatever quantity squared. So if we're supposed to evaluate this thing for x equals 10 inches, so if I put a 10 here, must put a 10 there, and a 10 there. And what we have is 40, and 18 minus 10 is 8 times 8, and we're going to square that. So now we have 40 times 64. And so v of 10 equals, well, 4 times 64 is 256. Tag a 0 onto that, and we have 2560. And that's going to be in terms of inches cubed, and we are done.